So the first question that you should be asking yourself is, what is a class, right? And a quick Google search would let you know that in Java or in all object-oriented programming languages, a class is a blueprint or a template for creating objects, right? So now you should be asking yourself, what is an object, right? And so I don't know, for me, like, just talking about these concepts is kind of theoretical, and I'm not good with that. So I like talking about like concrete examples. So we can look at this here, okay? And so if we look at this main, you could see I have here an x and a y, and these two variables here describe a point, right, in space. And then I'm doing a print line, and I'm saying my point is at, this x and this y, right? And then here on line 10, I'm running move x, right, a function here called move x, and I'm giving it my current x position and how much I want to move it, right? So then here on line 10, it's going to jump down to line 15 with x being equal to 5 and dx being equal to 5. No, I'm sorry, x being equal to 0 and dx being equal to 5. And then it's going to do the calculation, add those two together and return that value. So then when it returns, it's going to take the 0 plus 5, which is 5, and it's going to return it right here. So that expression is going to be replaced with the number 5, and x is going to be equal to 5, right? So what move x is doing is it's moving this like x position by this much, right? And then I'm printing out the new position of x and y, right? So I go ahead and I compile that, and then I'll run it, and you could see my point was at 0, 0, and then after running move x, my point is now at 5, 0, right? So pretty straightforward. And so like this doesn't beg the question, like, why do we need classes? Why do we need objects, right? But what if I wanted to make a method like public static int? I don't even know what I would return there, but I would say move x and y, right? So I want to, I don't know what the word is, but I think it's like translate, or I'm not sure what it is, but you want to flip on the x and flip on the y. So basically flip on a horizontal line across the x and y coordinate system, right? So how would you do that? Well, you would say int, you would take in some value like int x and int y, and then you would take in the dx and the int dy, and then you would do some magical math, right? Magical math, whatever it is you want to do to it. And then here we would need to return x, and we would also need to return y, all right? So then when we're up here and we run move xy, right, we give it x, we give it y, we say we want to flip it, or I guess we don't even need a dx and a dy because we know we just want to flip it, right? So I think what the magical math is going to be doing is it's just going to be reversing the signs of x and y. So I guess we would just go ahead and say negative x and return negative y, right? And then we would want to do something like x and y are equal to the return value of move x, y, right? And so like if I go ahead and compile this, it's like, oh, this is not a statement. And even if I remove that, it's going to talk about how this function has like an unreachable return statement, right? And that's right, because when it comes down here to run move x, y, it's going to run the first return, which is going to come back up here into the static void main, returning the value negative x. All right. So what's the problem here? The problem is that you cannot in Java, you can't return two values from a method, right? Or from a method. So how do we get around this problem? Well, we can create a class, and we can deal with an object, right? Because what is an object? An object is a collection of variables, right? So you can have a class with just one instance variable. That's true. But there would be no point in that, right? Because if it was just one instance variable, then we could just have it be a variable in main and deal with it in main, right? The point of creating classes, well, one of them is so that we can have a collection of variables that can be manipulated in the different associated methods, and we could effectively return two or more values, right? So let's go ahead and rewrite this using a point class. Okay, so I'm going to go ahead and do this here. So what did I do? We're looking right here, right? And so I have my point class file. It's this one here. And then I have my tester, which has my public static void main, right? You don't mix the two. So you never put like static void main here after creating your class point, right? So when we were doing Python, that's the way we did it. Because they allowed us to, and I believe you can actually do it here as well. But for our files, we would want to keep them separate, just because that's the format that they use on the exam, and it's just the standard convention that Java programmers use, right? So if you're making a small little file and you want to test the class really quickly, yeah, you can write public static void main in here. But generally speaking, like the file that creates the objects from the class are separate from the class. Okay, so that's the convention that we're going to use. We're keeping our class separate from our main, where we are going to create objects of this class. Okay, so going back here, what is a class? It is a blueprint. Okay, so in your mind's eye, you should be thinking this is a piece of paper, like the blue and white piece of paper where they have blueprints for houses. That's what this guy is, right? It is a two-dimensional piece of information. Okay, and then when we create an object here in static void main, we are building the house. We're creating a 3D object in 3D space. Okay, so this guy here is just a blueprint, and if you look at my blueprint here, I have two instance variables, right? So if I make an object of type point, it's going to have two instance variables. I think they're referred to as instance fields. They have a different like 3 or 4 different synonyms that refer to the same thing, right? So we got to kind of get our head wrapped around that. You could see that they are private, and I guess I won't talk about that now, but we'll talk about it later on. We have an int x and an int y, and then we have our constructors. Okay, so the constructor is what builds the object. So when I'm over here, I'm going to go ahead and erase all this stuff. Well, maybe I could leave it. Just erase the void main. I want to go ahead and create an object of type point. So how do I do it? Well, I got to make a variable that will contain that object. So I say point p, right? So this is making a variable called p, who can hold objects of type point, right? Just like how before we said string s is equal to something, right? Well, string is actually an object. So what we really should have done was say new string, and then in the parentheses we would give it a string that we want to create, right? So what is happening here? Well, we're making a variable called s that's type string, can hold string objects, and it's going to run the constructor new string for the string class, right? The constructor for the string class takes in an argument, this string, right? And for each letter in that argument, it stuffs it into an array. And the string class has one instance variable, which is an array of this size, right? However many characters there are here. So that's what the string class is. But we're not talking about the string class. We're talking about the point class, right? Our class. So point p is a variable called p, who can hold type objects of type point. And we're going to say equals new name of the class point. And then we have two options here. We have the option of using this constructor, or we have the option of using this constructor. Okay, and constructors are different from other methods because they do not have a return value. Okay, so notice that. And also they are always named the same name as the class. Okay, so right, so if I run this, which constructor is it going to run? Is it going to run A or B? Well, of course it's going to run A, right, because I gave it no arguments. And what is it going to do? It's going to come over here, and with my newly created instance variables x and y, it's going to set the x equal to 0 and the y equal to 0. Okay, that's what this is going to do. All right. So I guess now would be a good time to talk about toString, right? toString is another magical method, just like the constructor is a magical method. And when I say magical, I mean there is code in the background in the compiler for Java that treats the constructor differently than other methods and treats toString differently from other methods. Okay. Other methods follow a defined behavior, like they will run exactly the way that you define them to run. You call them over here. they come over here and run, and they come back, right? The constructor is special because you need to run it by saying new and then the name of the constructor, right, or the name of the class, and then it will come over here and run the constructor, which will also create the instance variables up here, right? So it will create the instance variables, put them in memory, and then it will run the constructor and set them equal to the initialized values that you want to set them equal to, and then it's going to come on back here, and then P is going to be equal to that memory location where those variables are contained. All right. So that's why the constructor is kind of special. And then why is toString special? toString is special because it always has the same purpose. All right. Its purpose is to print out in a user-friendly format all of the values of the instance variables. All right. So what do I do here? I return, I don't system print line. The toString method returns a string that contains the values of the instance variables. And when I say that, I don't mean just print out the value of x and comma the value of y. I mean say x, like semicolon, the value of x, and then y, comma, y, semicolon, the value of y, right? So we're going to return this like user-friendly string. And so toString, how do you get it to run over here in main? You do system.out.println, and then you put the name of the object inside of it, right? So our object is stored in the variable p. So then if I compile that, okay, I can erase this, and then I compile that, and then I will run it. Where is it? Okay, so I'm here in tester, I run main, and then you can see it prints out my x and y values, right? Now here's another option. We can run the two argument constructor. Okay, so how do we do that? Well, here in a constructor we give it two arguments, right? We give it a 4 and a 5. So then when it comes to run the constructor, it knows not to do this one. It's going to look for a two argument constructor, and it's going to run this one, right? So my x variable is going to be set to xpos, and my y variable is going to be set to ypos. And so I'll go ahead and compile that, and then I will run it here, and I will run it, and now our x is equal to 4 and our y is equal to 5. Okay. Yeah, and so when we do this, we're creating a 3D piece of data that is described here in point, right? This 2D piece of paper. And so, yeah, that's how toString works, right? So you do system print line, put the object in there, and then toString needs to return a string containing the values of the instance variables. All right. So I guess one last point that I want to go over before ending this video is right here when we run the two argument constructor. All right. These variables xpos and ypos, they are temporary variables for this method, right, for the constructor, and so they could be any name that you want them to be, and very often people name them the same name as the instance variables in which they will be set to, right? So we do that. And so if this is the case, then we have a bit of ambiguity, right? Because we're saying, okay, x is equal to x. Well, which x are we talking about? Are we talking about this instance variable that was created for the point class? Or are we talking about this x variable, the instance variable for the point class, like this temporary variable or this instance variable, right? Which one are we talking about? So the way that you can have this work and not have any ambiguity is use the this period, right? So what does this mean? This means that when I talk about this x, I'm talking about the instance variable x, okay? And so this is not the only like place where you can use this. Some programmers use this like every time they reference the instance variable here in the point class, and so that's completely fine. You could do that, right? So this is optional, but it is not optional when you have a situation where the instance variable, the temporary variables coming in have the same name as the instance variables of the class. So yeah, I guess we should stop there.